Okay. All right. So the next part is if f is differentiable at x equals c, then it's continuous. It makes sense. If you can find a slope value at a particular point, you must have that particular point, and it must be that it agreed from left and right. So that's creating the smooth part of this. All right. So number one, if function is differentiable, then it's continuous. So differentiability implies continuity. It's possible for a function to be continuous and not be differentiable. We just saw that on these two, right? So at one, this is continuous the whole time. I could draw that whole thing without picking up my pencil, but it wasn't, there was no derivative at one. We had a cusp. And then there was no derivative here at zero because it went to infinity. What would you even call it? So now, of course, over this, we did not have continuity, so no big deal. Okay, now, the next thing is it wants you to write the contrapositive. Now, you may not remember from geometry, that would have been your freshman year, but the converse of a statement, you switch the if and the then. All right. The inverse of a statement is you negate the if and the then. The contrapositive is you do both of those. So here it is. If a function is not continuous at x equals c, then it is not differentiable at x equals c. It kind of makes sense, right? If it's not continuous, how can you possibly have a slope value if there's no value at all? All right. So example 4, describe the x values at which it is differentiable. Justify your answer. Okay. Now here's the thing. Hard to see, but these definitely have a cusp whenever this function is equal to 0. Well, this function is equal to 0 at two places. Whenever the part inside is equal to 0, and that happens when the part inside x squared minus 5 is equal to 0. Okay, well, that's true whenever you add 5 to both sides and take the square root. That's true whenever x is equal to plus or minus the square root of 5. This is where the cusp occurs. All right, so this is going to be differentiable everywhere except for them at that moment. So I could go from negative infinity to the negative square root of 5. All right, and then leave that point out, go from that point to the positive square root of 5, leave that point out, and then go to infinity from there. So here we go. So here's how I would say it. It is differentiable. G is differentiable at all points except x equals plus or minus the square root of 5. And the reason, it says to justify your answer. G, the graph of G, let's say the graph of G, just to be precise here. All right. The graph of G has, you could say sharp points, sharp turns. I'm going to say cusps at those 2 points. Boom. Okay, so there we go.